Okay, girls, I made a video on continuity, uh, but Clipchamp, I used Clipchamp to avoid watermark. So Clipchamp doesn't allow me to record video for more than 30 minutes. So I made three individual videos and then punched them together to make one file. So in between, you will find two gaps. So don't worry, just keep watching. You will get the rest of the portion more or less in a continuous way. And another thing is like one of your friends requested to make a video on 3D, but the thing is, I don't know whether all of you have already finished the chapter on vectors or not. So let me know. If you think you are comfortable with vectors, then I will make a video on 3D directly. Uh, you don't have much time, so uh, let me know, please. You can write it in the group also, right? And continuity, I have done some sums. If you have any other sums, you can send them to me. And also let me know whether I need to do a video on differentiability, because in NCRT we don't have many sums on differentiability, but in the board exams, more or less every year you get one sum on differentiability. Okay, so do let me know. And please like my video and try to subscribe. I mean, you already subscribed, tell others also to. Okay, bye.
Okay, so I'm starting with continuity. So, definition of continuity. So, first point, and of course, we are talking about real functions only. So, let f be a real function and a and c be a point in the domain of f. Also, let us suppose that the domain is, instead of taking the whole of R, suppose the domain of the function is a subset of R, say AB. So that means this is the domain, this is my real number line R, so A, B. So the function is defined only in this portion, suppose. And C is a point, any point in this domain. Now, what do we mean by the fact that f is continuous at C? So, f will be continuous at the point x equal to C if left hand limit equal to right hand limit at C equal to the value of the function at C. That is, limit of the function f as x tends to C from the left, that is your left hand limit, equal to limit x tends to C plus, that is approaches x approaches C, sorry, one second, x approaches C from the right fx, so that is your right hand limit, left hand limit equal to right hand limit equal to the value of the function of C. Now in class 11 actually you have seen that this portion ensures that the limit exists. The limit of the function at x equal to c exists if LHL equal to RHL. So for continuity, we add another condition that this LHL equal to RHL, the common value is nothing but the value of the function at c. So that's the definition of continuity. Now, here we have discussed, let me name it A, the function continuous at a particular point C within the domain. Okay. Now, suppose that point is A or B, that is the boundary points. So, if x equal to A then if continuous at x equal to a, if, now see here, the function has no existence on the left side of a because it is confined to its domain ab. So here there is no question of discussing left hand limit. So only right hand limit at x equal to a equal to functional value at a. That is, limit as x approaches a from the right, fx equal to fc. That means in this case, the x approaches a from the right only. There is no existence of x beyond a, that is left of a. So that is what happens for the boundary points. So similarly, if your x equal to b, then f continuous at x equal to b if only the left hand limit equal to the functional value. That is, limit x approaches b from the left equal to fb. Here, sorry, I made a mistake. This will be fa because you are checking the continuity at a. So in the third case, that is c, your x approaches b from the left only because the domain ends there. So that is how we define continuity of a function at particular points in the domain. So those points may be the boundary points or a point inside the domain. And the last thing that we have to know is, what do we mean by the fact that f is continuous over the whole interval? So f will be continuous in the whole closed interval AB, that is the entire domain, if number one, f continuous at A, f continuous at B, and third, f continuous in the open interval AB. Now, this portion and this portion can be shown easily. But how do you show that it is continuous in the open interval AB? Because it consists of infinitely many points within AB. So that is the process is, you choose arbitrarily any point C in AB and show that it is continuous at C. Since you have chosen C arbitrarily in AB, so it is continuous over the whole open interval AB. So that is how we prove continuity of a function as required in the question, whether it is a point or an interval. So from this definition, obviously one thing follows, that what are the conditions under which f might become discontinuous. So let's take a quick look. F may be discontinuous at a particular point C belonging to the domain AB if. So there are various conditions under which it might become discontinuous, out of which the most basic condition is the function is not defined at C. That is, if C undefined. Now, in your textbooks, this condition is included as one of the conditions where function becomes discontinuous. But actually speaking, that's not true, because when we speak of continuity of a function, we, without saying or mentioning anything, it goes without saying by default that we are discussing the continuity of a function in its domain. So if a function is not defined at a particular point, we don't include that point in the domain. For example, tan x. If you consider the function tan x, then you know that tan x is not defined for at all odd multiples of pi by 2. Not defined. So this is not defined at 2n plus 1 pi by 2 where n belongs to z. So naturally, when I say whether tan x is continuous or not, if you consider the whole of R, obviously it is not continuous. But in higher mathematics, in higher classes, when we say tan x continuous, what we mean is tan x is continuous in its domain, which does not include the odd multiples of pi by 2. So that is, remember that. But since your textbooks contain this uh, condition that if it is not defined, then it is discontinuous, so I'm including the point. What else may happen? The thing is, your left hand limit left hand limit or right hand limit might not exist. Might not exist. So that might happen. Then the function will be discontinuous at x equal to c, might not exist at x equal to c. Third is, they exist. Both LHL and RHL exist, but LHL, RHL both exist, but they are not equal. So LHL not equal to RHL. Again, function will become discontinuous at x equal to c. Fourth is, suppose LHL equal to RHL, that is they exist and they're equal, but they are not equal to the functional value. Then also it will become discontinuous. So these are the various conditions under which a function might become discontinuous. So there is not much theory in continuity. What we really need to do is sums. So let me now shift to some important sums that usually come in the board exams. So I'll start with a bit of simple short questions, and then we'll move on to the larger one. I mean the longer questions. So this type of question is very common. This came in 2017 board paper. That is, fx is given to you as kx by mod x when x is less than 0 and 3 when x greater than equal to 0. So this is function is given to you. Also it is given that f is continuous at x equal to 0. This is given. So your job is to find the value of k. So this is a very common type of question in the boards. So let's solve it. Now, whenever there is a mod, I always I taught you that remove the mod and redefine the function. You know the definition of mod is mod x equal to plus x when x is greater than 0, 0 when x equal to 0, and minus x when x is negative. This is the definition of mod function. I taught you in class 11. So if I keep that in mind, I can redefine the function fx as when x is negative, that is the first branch, then mod x is minus x. So obviously it will be kx by minus x, that is just minus k when x is less than 0. And the second branch, there is no mod, it's a constant function, a constant value. So 3 remains 3 when x is greater than equal to 0. So we redefine the function removing the modulus. Now let us calculate the left hand limit. So left hand limit is limit of the function fx as x tends to, we are calculating the limit at 0. So it x tends to, that is x approaches 0 from the left. That means this ensures the fact x approaches 0 from the left. What does it mean? It means that your x is less than 0. So accordingly, you will choose the branch. So that means the first branch. So that is here, sorry. First branch here. That means fx will be minus k. So that is limit x tends to 0 minus the value of the function is minus k. That is the first branch. And since it is a constant, the if there is no effect of the limit, that is x approaches to which point has no effect on a constant, so it is minus k. So your left hand limit is minus k. Now let us see what is my right hand limit. Right hand limit is limit x approaches 0 from the right fx. Now let's see what is fx. That now it is a second branch and that is 3. So again it's a constant. So it is 3. Now it is given in the sum that the function is continuous at x equal to 0. So if continuous at x equal to 0 implies my left hand limit equal to right hand limit equal to the functional value at the point, that is 0. So from here your left hand limit is minus k and your right hand limit is 3, and you don't even need this because, but if still if you write f0 when x equal to 0 it is 3, so there's no need. So from here you have k equal to minus 3. So that's a short question. Next, this is not a short question. I think it had, oh no, it was 1 mark question, yes. So this also came in 2017, 1 mark question. Fx equal to x plus 3 whole square minus 36. I will not read out the sum as I am writing it, giving a bit of rest to my voice. Also, it is given that if continuous at x equal to 3. So you have to find the value of k. So exactly similar to sum number 1. So now I'm not going through so many steps, directly calculating left hand limit. So limit x approaches, because the point here is 3. So x approaches 3 from the left. Now x approaches 3 from the left means x is always less than 3. Now here the difference between the first sum and second sum is this condition. X not equal to 3 implies that x is less than 3 and x greater than 3, both the conditions are punched together here. So even when x is less than 3, we'll take this branch. When x is greater than 3, we will take this branch. So coming back to left hand limit, my x is less than 3. So this is the branch. So x plus 3 whole square minus 36 by x minus 3. See, if you try to calculate the limit here, you will see that you will get 0 by 0 form, that is indeterminate form. This is from the limit chapter of class 11. So obviously we have to manipulate this expression to get remove the problematic factor that is making it indeterminate. So here it is obvious, a square minus b square. So a plus b into a minus b by x minus 3 limit. And yes, don't forget to write this limit part, then you lose marks, and I think you will lose it heavily. Be careful. So you can see that this factor and this factor gets cancelled. Why? You are dividing numerator denominator by x minus 3, that is cancellation. And why you can divide it by x minus 3? Because x approaches 3 means we have seen in the concept of limit that when x approaches 3 from either left or right, this means that x is never equal to 3. It is very, very close to 3, either on the left side or right side of 3, but never equal to 3. So this ensures the fact that x minus 3 factor is non-zero. And that is why we can divide it by this. So now the indeterminate form is gone. Here, if you calculate the limit, so this is 6 plus 3, 9. So limit x tends to 3 minus x plus 9. This is a polynomial function, and you know from class 11 that to calculate the limit of polynomial function, you simply replace x by 3. That is the number towards which x is approaching, irrespective of direction. So if you put it, it is 12. So here you observe that this is your left hand limit. Now if you try to calculate right hand limit, since right hand limit means x greater than 3 and the same branch will act, so it is pretty obvious that your right hand limit will also be 12. So whenever the condition is given like this, two condition punched together, just don't bother to find the right hand limit because it will be 12. So LHL equal to RHL equal to 12. Now, what is the value of the function at 3? It is k. So we can ignore RHL for the time being because we know it will be 12. So now f is continuous at x equal to 3. That implies our LHL must be equal to the value of the function at 3. So this implies 12 equal to k. So the value of k is 12. Next sum, sum number 3. This was a 4-mark sum. This is a 4-mark sum. It came in 2016 board. Here the function fx is defined as, it is given to us as 1 minus sine cube x by 3 cos square x when x is less than pi by 2, p when x equal to pi by 2, q into 1 minus sine x by pi minus 2x whole square where x is greater than pi by 2. So this is how the function has been defined for us. Also it is mentioned that f is continuous at pi by 2. So your job will be to find the values of p and q. As you can see, actually the sums of continuity are basically sums of calculating limits. So if your chapter on calculation of limits is thorough, then continuity won't be a problem at all. Anyway, let us take. So here the continuity is discussed at the point pi by 2, and you can see there are two different branches for x less than pi by 2, x greater than pi by 2. So this will give us our left hand limit and this will give us our right hand limit. Okay. So let's start. Left hand limit is limit x approaches pi by 2 from the left. Now from the left means the first branch is acting because here it is x is less than pi by 2. So it is 1 minus sine cube x by 3 cos square x. So again, this reduces to calculation of this limit. So how do I do it? Limit. Okay, let me do one thing. Instead of writing limit again and again, let me just copy this portion separately, and show how I simplify it. So 1 minus sine cube x by 3 cos square x. It is just trigonometric manipulation and nothing else. Because here you see, if you put x equal to pi by 2 directly, then you get indeterminate form 0 by 0. So there must be some Gondogol factor inside it, which we have to bring out and cancel. So let's see which is the Gondogol factor. So if you apply a cube minus b cube, then it is a minus b into a square plus ab plus b square by, now here instead of cos square x I will write 1 minus sine square x. So you can see from the denominator, that is this 1 minus sine square x, you will get two factors. One is 1 plus sine x and the other is 1 minus sine x, a square minus b square formula. So in the very next step, what will happen? This 1 minus sine x and this 1 minus sine x will cancel. So you will be left with only 1 plus sine x plus sine square x in the numerator, and in the denominator you will be left with 3 and 1 plus sine x. Now you see the indeterminate form is gone. So this is equal to, I'm writing it here. So this is limit x tends to pi by 2 from the left, 1 plus sine x plus sine square x by 3 into 1 plus sine x. So now if you just plug in the value x equal to pi by 2, then you get the value half. So that is your left hand limit. Now let us calculate right hand limit. So right hand limit is limit x tends to pi by 2 from the right. So this time x is greater than pi by 2. That means my third branch will be the value of the function. So q into 1 minus sine x by pi minus 2x whole square. So now it boils down to calculation of this limit. Uh, in this type of limit calculation, the best thing to do is, I'm doing it separately here. Right. So if you take, let pi minus 2x equal to h. So as x tends to pi by 2 from the right, this means, see, this x is approaching pi by 2. That means 2x is approaching. So this means x approaching pi by 2 means 2x is approaching 2 into pi by 2, that is pi. It is approaching pi from the right. That means h approaches. So if this whole thing approaches pi, then pi minus pi, so h approaches 0. So if you make this substitution, that is you change over from x to h, then in terms of h, the limit will be h tends to 0 from the right. Okay. So, and what will happen to the numerator? Now let's see, it is, oh, the numerator contains sine x. So that means sine, from here, from this substitution, you can see that 2x equal to pi minus h. So x will be pi by 2 minus h by 2. So sine of pi by 2 minus h by 2. So this is how we simplify this. Now let us put, okay, so the problem is Clipchamp doesn't allow me to record video for more than 30 minutes. So I will have to make the video in several parts. So let's continue with the sum. We were calculating the right hand limit. So I've shown you how to simplify this. So now we are going to actually I've substituted the values from this simplification here. You can see now after this step we are trying to approach this limit. So limit x tends to pi by 2 plus q. Now let me bring the 2 outside the constant part. So here you have sine square h by 4. So that is sine h by 4 whole square. Okay. Now in order to use this limit, I need to have h by 4 here. So that is h by 4 whole square here. I need to have h by 4 whole square here to apply this limit, right? But we have to make the adjustment because h square is there, and you have actually divided it by 16. So multiply that with 16 in order to preserve h square. So finally what happens? This 16 comes outside. So 2 by 16 uh, limit x tends to pi by 2 plus sine h by q sine h by 4 by h by 4 whole square. So this limit, okay, I made a serious mistake here. That is, when I'm changing my variable from x to h, I should have written h tends to 0. All these will be h because we are no longer in x. Extremely sorry. Actually, I'm doing it in a hurry to cover as much as possible. So h tends to 0 from the right. 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 So ultimately, this limit value is 1. So you have q by 8. So that is my right hand limit. Okay. So we have calculated the right hand limit. So similarly, now we will calculate the left hand limit. Um, okay, left hand limit, I think we have already calculated. Yes, we have calculated. Left hand limit is half and right hand limit is q by 8. Also, it is given that the value of the function at pi by 2 is p. So since the function is continuous at pi by 2, since f continuous at pi by 2, we have left hand limit equal to right hand limit equal to value of the function at pi by 2. So that implies our left hand limit was half, right hand limit is q by 8, and functional value is given to be p. p. So from here you get p equal to half and q equal to 4. So that's with the sum number 3. Now let's come to sum number 4. Here fx is given as sine a plus 1x plus 2 sine x by x when x is less than 0, 2 when x equal to 0, and root 1 plus bx minus 1 by x when x is greater than 0. So this is how the function is given to us. If continuous at x equal to 0, you have to find the values of a, b. So again, it is a similar type of sum, only the calculation of limits will change. So I'm just showing you the calculations of the limits. So left hand limit is limit x tends to 0 from the left first branch sine a plus 1x plus 2 sine x by x. So I split it from here. So limit x tends to 0 minus. So this is sine a plus 1x. In order to apply the standard limit formula, I need a plus 1x here, but there is no a plus 1 here, so I adjust it. So that's with the first part, and second part is 2 sine x by x. So now you can see this part as x tends to 0, this part sine a plus 1x by a plus 1x, this part will yield the value 1. X tends to 0, this part will yield 1. So ultimately the value becomes a plus 1 plus 2, that is a plus 3. So that's my left hand limit. Right hand limit, x tends to 0 plus x greater than 0, so the third branch 1 plus bx minus 1 by x. So here we apply this method, the method that is very similar to your that rationalization process. So 1 plus bx plus 1 by root 1 plus bx plus 1. So this becomes limit x tends to 0 plus. So this is a square minus b square, numerator a plus b into minus b. So a square 1 plus bx minus b square, that is 1. And here x into root 1 plus bx plus 1. So this is equal to, the b comes outside, limit x tends to 0 plus x by x into root 1 plus bx plus 1. Since x approaches 0, x is not equal to 0, so we will cancel the x's. So you have finally b limit x tends to 0 plus 1 by root 1 plus bx plus 1. So now if you put the value 0, this is equal to 1 by b by 2, right? b by 2. So this is my right hand limit. So since if continuous implies LHL equal to RHL equal to value of the function at 0. So LHL, we have got a plus 3, RHL we got b by 2, and the functional value is 2. So from here you get a equal to minus 1, b equal to 4. Right. Next, sum number 5. This is a short question. Fx equal to e to the power 1 by x minus 1 by e to the power 1 by x plus 1 when x not equal to 0. So this ensures that LHL equal to RHL, both the branches included, and minus 1 when x equal to 0. So the question is f continuous at x equal to 0? LHL will be equal to RHL, that much we can see. But whether that will be equal to the functional value or not, we have to see that. So since LHL are equal to RHL, we can here just write like this: LHL equal to RHL equal to limit x tends to 0, that is the limit, no plus minus, e to the power 1 by x minus 1 by e to the power 1 by x plus 1. So we just need to simplify this, because you can see this is again another indeterminate form, infinity by infinity. So we have to adjust it. So what we do is we divide both sides, that is numerator and denominator, with e to the power 1 by x. So this becomes 1 minus 1 by e to the power 1 by x by 1 plus 1 by e to the power 1 by x. So what we are doing is dividing numerator and denominator by e to the power 1 by x. Actually, you can see the thing is, since x tends to 0, 1 by x, as x tends to 0, 1 by x tends to infinity. But if we can change it, that is, if we, this is in the numerator as well, so infinity by infinity. But if x tends to infinity, then 1 by x tends to 0. We know that. That is why we have brought the e to the power 1 by x down. That's the point actually, to avoid this. So sorry again, I keep forgetting writing this, but if you forget, then you will lose marks. 100% guarantee. So now this is equal to, if you calculate the limit, x tends to 0, 1 by x, here I have written x tends to 0, x tends to 0. So 1 by x tends to infinity. That means 1 by infinity tends to 0. So this portion tends to 0. This portion also tends to 0. So ultimately the value of the limit is 1. But the functional value f0 is given to be minus 1. So here we see LHL equal to RHL not equal to the functional value, that is minus 1. So this means that f discontinuous at x equal to 0. Now the before going into further sums, now let me explain a bit of theory that is left we have to do, and that is properties of continuous functions. Properties of continuous functions. I'll try to quickly cover it, because again clipchamp will suddenly terminate it. So number one, so here first we assume that let f g be continuous functions. Then number one, f plus minus g will be continuous. Number two, f into g will be continuous. Number three, f divided by g, provided g not equal to 0, will also be continuous. Another important thing is uh, some important points to remember, because these points help in doing some sums. That is, number one, all polynomial functions are continuous over R, and hence also over any real intervals. That is, subsets of R. Second, sine, cosine functions are continuous over whole of R. Now regarding tan x, if I say tan x is continuous over R minus 2n plus 1 pi by 2, which is actually the domain of tan x. So then it is continuous. But if you consider the whole of R, then it is discontinuous. Tan x discontinuous over R. That's a point I was trying to explain in the beginning. And then last four is an exponential function, that is a to the power x, where a is greater than 0 and a not equal to 1. This function, and log function, that is log ax, again where a is greater than 0, a not equal to 1, and of course x is positive. That's the domain of log function. It acts only on positive. So these two functions, they are continuous in their domains. In their domains. Just I'll try to quickly explain it through a graph, very simple one. So for this is for ax and this is for log. Now for ax, the graph is like this. I've explained to you earlier. This is asymptotic here, and this point, this is 0 1 point. This is a to the power x, and log graph is like this, asymptotic here and passes like this. This point is 1 0. So domain here is the whole of R. You can see the whole of xx dash is acting as the domain, but here the domain is only positive, this thing, 0 to infinity. 0 is not, the log 0 is not defined. That means exponential functions are continuous over whole of R, and log functions are continuous over the positive real numbers. Okay, so now, as I was telling, that these properties help you to do some sums. As an example, I'm doing a particular sum from your NCRT exercise. In my old book, it is exercise 5.1. Exercise 5.1, sum number 24. Here, the function is defined like this: fx equal to x square sine 1 by x when x not equal to 0, and 0 when x equal to 0. Again, this sum is a very important sum, often comes in the exam. So now this sum, okay, the question is f continuous? Is f continuous at x equal to 0. Now this sum can be done by two different methods. First, let me show you method 1, where I will use the above properties. So what I'm doing is, uh, first let us consider when x not equal to 0. That is the first branch, x not equal to 0. So we are investigating only the first branch now, that is when x not equal to 0. Now, since x square is a polynomial function, so it is continuous at 0. In fact, it is continuous over whole of R. Also, sine 1 by x, obviously x is not equal to 0, is also continuous at x equal to 0, in fact, over whole of R. Therefore, by algebra, that is, uh, product of two continuous functions is continuous. So, by algebra of continuous functions, the product of the two, that is x squared sine 1 by x, is continuous at x equal to 0. So this is part A, when x not equal to 0. Next, when x equal to 0. Okay. Now when x equal to 0, left hand limit equal to limit x tends to 0 from the left, x square sine 1 by x, that is equal to limit x tends to 0 from the left. Now here we do a simple manipulation. We keep 1x here and then sine 1 by x, and the other x that was here, we bring it here to bring this form. Now you know that this portion, as x tends to 0, this portion will give you 1. So ultimately you are left with x tends to 0 minus x, which is 0. The same thing will, the same treatment for RHL. So I'm not explaining this again, exactly same thing. Limit x tends to 0 plus, here also the answer will be, by same manipulation, it will be 0. And the functional value at 0 is already given to be 0. Therefore, LHL equal to RHL equal to functional value. So, fx continuous at x equal to 0. So, this is method 1. Another method which I prefer is this. Method 2. Okay. So, if you remember, we did something called sandwich theorem in class 11 limit chapter. So, we are going to use sandwich theorem here. Okay. So, now my function is, I'm not writing it again. You know the function. So, what I'm doing is, we know that sine of anything, of course, here it is given x not equal to 0, otherwise it won't be defined. Sine of 1 by x will lie between -1 to 1. That's the range of sine of anything. right? Now from here, I want to come to the expression sine square sine 1 by x. So I multiply throughout with x square. So minus x square lesser equal to x square sine 1 by x lesser equal to x square. Okay. Now let us see the limit of the two extreme functions, that is this function and this function. Okay. So minus x square and uh, no, 1 second. Limit x tends to 0 minus x square equal to 0. Now see here I have written just x tends to 0. I have not written plus or minus because this is a polynomial function. Even if you take plus or minus, you simply put substitute x by 0. So both LHL and RHL will be 0. So basically this is both LHL and RHL. That is the limit of this polynomial function is 0. Similarly, x tends to 0 of the right hand extreme function, that is x square, again by same logic will be 0. Polynomial function continuous everywhere, so at x equal to 0 also continuous. So now sandwich theorem says that if you have this is just, let me remind you the sandwich theorem once. Sandwich theorem, it says that if you have three functions like this, gx less or equal to fx less or equal to hx, and limit as x tends to a gx equal to limit x tends to a hx, then sandwich theorem says that the middle function will also have the same limit. X tends to a fx will also have the same limit. Suppose this common limit is, say, some value, say p. Limit of gx and limit of hx is suppose p. Then sandwich theorem says that the middle function as x tends to the same number a will also be p. That is what is the theorem states. So if I now apply this theorem here, then therefore by sandwich theorem, limit x tends to 0 of the middle function, that is x square sine 1 by x, is also 0. Right? So this is the limit of this thing, the middle function, that is LHL and RHL, both of the function is 0, and it is given the functional value is 0. Hence, x square sine 1 by x continuous at x equal to 0. So this is method 2 using sandwich theorem. Also, I would like to show you the geometrical figure of this function because it's very, very interesting. What is happening is you are binding x square sine 1 by x between two functions. One is minus x square, the other is x square. You know that these two are parabola actually. This is a parabola, this is a parabola, right? Y equal to minus x square, y equal to x square. These two are parabolas. So the graph is something like this. So first let us draw the parabolas. Y equal to x square. Y equal to x square is this parabola. Uh, Let me draw with a red one. So this parabola is y equal to x square. And y equal to minus x square is this parabola. Y equal to minus x square. And x square sine 1 by x, if we try to plot the graph, it will lie between this. That means, the function will be like this. So you are forcing the function by the two parabolas to approach 0. Because otherwise, if you don't limit sine 1 by x, x square, x square sine 1, sine 1 by x, just if you look at the function sine 1 by x, then let me show this, then you can appreciate this better. If I take only the function sine 1 by x, when x not equal to 0, and 0 when x equal to 0. If you simply consider this function, then the graph is very erratic. It is like this. Of course, sine lies between 1 and minus 1. So if this is my y equal to 1 and this is my y equal to minus 1, then sine 1 by x is like this. It oscillates. This is called oscillatory function. It oscillates like this. Initially it will have some bigger gaps, then gaps will it will start reducing, and it will become more and more erratic as it approaches 0. Very erratic, like this. Similarly here also, initially the gaps are bigger, gaps get closer, and then every moment it jumps up and down, up and down, up and down. So what happens is, for this function, when if you consider the point 0, this is 0, on the left side of the, if you consider a small interval, if you consider a small interval on the left side of 0 as well as on the right side of 0, very small interval, in that small interval also the function will jump, oscillate like anything, পাগলের মতো ওঠানামা করতে থাকবে. So the left hand limit will, neither the left hand limit will exist nor the right hand limit will exist. So in that case, the limit will not exist at all. So in that case, the limit, left hand limit, right hand limit will not exist. Left hand limit, right hand limit will not exist. Because when x approaches 0 from the left, you cannot, as a function constantly oscillates between 1 and minus 1, you cannot assign a value towards which the function will approach. It will keep oscillating. So in order to discipline the function, we bind it between two parabolas. So not only parabolas, we can bind it by two straight lines also. Like for example, if you consider the function fx equal to x sine 1 by x when x not equal to 0, and 0 when x equal to 0. Now for this function, you are binding it by two straight lines. Let's see what are the two straight lines. Uh, uh, y equal to, so here let me show the calculation. Sine 1 by x lies between minus 1 and 1. just like we did with the parabola. Same thing I'm doing here. That means if I want to bring x side, there I had to bring x square. So now I have to bring x side. So I multiply x both sides. So sine 1 by x less or equal to, that means the two binding functions that will bind and discipline sine 1 by x are y equal to minus x and y equal to x. These are two straight lines. So now if I draw the lines, this is my y equal to x and this is my y equal to minus x. So this is 0. So here what will happen is, again we are forcing the sine 1 by x function to approach towards 0. So as x approaches 0, the function also gradually it is forced to approach 0. So this way we can discipline this function either by binding between two lines or by two parabolas. Okay, so I think I'll finish this video here and make another one with some more sums. Okay, so this is the last video on continuity. So I want to discuss two sums here. The first sum is a bit lengthy, but it sometimes comes in the board exam and it involves mod. So let me do this sum. So the question is, find the points of discontinuity of the function fx equal to x minus mod x minus x square, where x belongs to minus 1 comma 1. So this is important. Okay, so what we do is, I told you if there is a just hold on for a second. I told you that if there is mod, always redefine the function. So first thing is we want to redefine the function. Now to redefine the function we have to break down the mod. Now let me do it here on the right hand side. Now here the function is fx equal to x minus mod of, if you take x common here, then it is 1 minus x. Okay. Now if you equate whatever is inside the mod, that is x 1 minus x equal to 0, then you get two values of x equal to 0 and 1. So these are the 2 points where I have to break the function and get different branches. That means if this is my number line, first of all, the function is defined, that is the domain of the function here is given to be minus 1 to 1. So you got 2.0 and 1 where you will make the break. 1 is already one of the boundary points. So 0 is suppose here. So this is how we break the points. I mean, already it is given minus 1 to 1 is the domain. So the only different point of break you get is 0. Suppose the function was given on whole of r, then whole of r would have been divided into minus infinity to minus 1 to 0, 0 to 1, and 1 to infinity. So we don't need to do that here, thankfully. So now we are going to redefine the function. So first what we'll take, the first branch that we will take is this one, that is x lies between minus 1 to 0, that is this portion here. So my the region in which x lies is minus 1 less than x less than 0, that is this region. Now if you calculate that if your x is here, you can just take an example. Say x equal to minus 0.5. Then what is the value of x minus x? I mean, whatever is inside the mod, is that positive or negative? That is what we want to find out. So in that case, x minus x square is minus 0.5 minus 0.5. So it is negative. And we know that for modulus mod x, if x is negative, then the value is minus x. So we apply this definition here. So in that case, what happens? The function, that is portion of the function outside the mod, remains as it is. But when we remove the mod, the expression inside the mod is coming to be negative when x is in minus 1 to 0 interval. So here it will be minus of x minus x square. That means it is, the value is 2x minus x square, right? 2x minus minus plus minus, right? 2x minus x square when x is in minus 1 0. So this is one branch. Next branch will be when x lies here, that is 0 to 1. So next branch is 0 less than x less than 1. So again, if you take one example and try to find out, say you take here 0.5. So when x is 0.5, x is 0.5, your x minus x square is 0.5 minus 0.5 whole square. So this is positive. That means when x lies between 0 to 1, the expression within the mod, that is this portion, is positive. So it will come out with a positive sign. Just as here it had come out with a negative sign, this time it will come out with a positive sign. So x minus plus x minus x square. So that means that this is equal to x, just x square. So second branch of the function is x square when this lies between this. So we have found the two intervals. Now let us try to find out what will be the value of the function when x is minus 1, 0 and 1. If you substitute x equal to minus 1, 0, 1 in the original function fx equal to this, then you can easily find out the value. So I'm not showing that. So in that case, it will be uh, minus 3 when x equal to minus 1, 0 when x equal to 0, and 1 when x equal to 1. So these are the different branches of the function. So let me just highlight it once. The first branch is this 2x minus x square when x is in this region. Second branch is x square when x is here. And third branch, rather third, fourth and fifth together, it is this. So I have removed the mod and redefined the function x, fx. Now, here they have asked find the points of discontinuity in minus 1 to 1. So we need not bother ourselves with the whole of R. So we will concern ourselves with only within minus 1 and 1. And here we saw that minus 1, 1 has been divided into two intervals. So we'll do the sum in three different parts. See, first we will individually check the continuity of the function at minus 1, 1, that is the two border points, and 0, where there will be a change in the nature of the function. So these 3 points we have to show separately. On and about the region between them, that is the open intervals minus 1, 0, 0, 1, we will simply use property to conclude that it is continuous. Okay, so let's start. So solution. So first, part A, we are checking continuity at x equal to minus 1 first. Now, as I told you before, since minus 1 is boundary point, there is no question of checking left hand limit. So we will check only the right hand limit. Okay. So right hand limit is limit x approaches minus 1 from the right. So that means what? X approaches minus 1 from the right. What does this mean? This means that x is on the right side of minus 1. That means x is greater than minus 1. Right? এটা এটাকে ইমপ্লাই করে না, নেগেটিভ সাইডে যত বাঁদিকে থাকবে তত বড় হবে। সো when x is greater than minus 1, remember you have a 0 here, and when we say x greater than minus 1, but remember it is very close to minus 1, that means x is in the interval minus 1 0, and hence my first branch will act here. So first branch was 2x minus x square. So instead of fx we write 2x minus x square. So now this is a polynomial function. You simply replace by x by 1. So you get minus 3. Right, minus 3. So this is your right hand limit. Now let us check the value of the function at minus 1. As you can see from the redefinition of the function, when x is minus 1, it is also minus 3. So functional value is also minus 3. So here we have right hand limit equal to the functional value, that is minus 1. So if continuous at x equal to minus 1. Okay. Next, we check continuity at x equal to 1, the other extreme boundary point. This process is similar, so I'm not explaining that much. Only thing to note here is, since this is the right hand side boundary point, my x will be approaching 1 from the left and very close to approaching 1 from the left and very close to 1. That means this time my x will be in 0 to 1, and in 0 to 1 the function branch is x square. So keeping that in mind, left hand limit equal to limit x approaches 1 from the left x square, so that is 1. Now let us take the functional value at a 1. Again you can see at 1 fx is 1. Therefore left hand limit equal to functional value. So if continuous at x equal to 1. Next, we check the continuity at x equal to 0. Now this will be somewhat different because here x can be both on the left side as well as right side. So we have to calculate both the left hand and right hand limit. So let us see. Left hand limit is limit x tends to 0 from the left. If x tends to 0 from the left, that means x is in the interval minus 1 0, minus 1 0. So minus 1 0 first branch, so that means 2x minus x square. So if you put the value, it is 0. This is left hand limit. Right hand limit is limit x approaches 0 from the right. So this time x is approaching 0 from the right. That means x is here in this region. That means in 0 to 1 interval. And 0 to 1 interval function is x square. So x square. which is also 0. And what is the functional value at 0? Again, you can see from the redefinition that it is 0. Therefore, we have left hand limit equal to right hand limit equal to functional value. So, f is continuous at x equal to 0. So, we have shown that f is continuous at minus 1, 1 and 0. Now, what we are left with is the two open intervals minus 1, 0 and 0, 1. This portion, we don't have to check anything. We simply write it like this. In or rather, let us write it this way. Since polynomial functions, please note that after redefinition of the function fx, if you look at the various branches of fx, the entire fx is polynomial function. This is polynomial function. Okay. So, okay. So this is a polynomial function. This is a polynomial function. And these, of course, are not only polynomial functions, they are special type of polynomial functions, they are constant functions. So the entire f in this interval minus 1, 1 is polynomial. So we simply write that since polynomial functions are continuous over whole of R, therefore they are continuous in subintervals of R. Intervals of R. So my fx is continuous in both the open intervals minus 1, 0 and 0, 1. We take open intervals because we have separately shown the points minus 1, 0, 0. So that covers all possible values of x in closed interval minus 1 to 1. So what do we see? Final conclusion. Therefore, f is continuous everywhere in minus 1, 1. So the question was find the points of discontinuity. Therefore, there is no point of discontinuity. There is no point of discontinuity of fx in minus 1, 1. So if your question is worded like this, that find the points of discontinuity, don't think that there will be points of discontinuity. This is just to mislead you. Okay. Again, you might have. So there's no indication there. You have to check it out. Okay. Now another type of sum comes usually in the short question portion. That I'm doing one type from that category. Uh, that is, your fx is given as log 1 plus ax minus log 1 minus bx whole divided by x when x not equal to 0. That's it. That's the definition given. And it says find f0. That is, what will be the value of the function when x equal to 0. When x is not equal to 0, it is given here. But the question asks you that when x equal to 0, what should be the value of f such that f is continuous at x equal to 0? That's the question. Okay. Now here you see the condition is x not equal to 0. That means x less than 0, x greater than 0, both covered here, which shows that your left hand limit, right hand limit will be same. So there's no question of calculating LHL, RHL separately. So we will simply calculate the limit. Okay. So limit x tends to 0, since that's the point we have to check. No plus minus, this is the limit, log 1 plus ax minus log 1 minus bx whole divided by x. Okay. Now first thing you do is you split it from here and you get two portions. So limit x tends to 0 log 1 plus ax by x minus log 1 minus bx by x. Okay. Now we are trying to approach this particular limit. If you remember from class 11, that is limit x tends to 0 log 1 plus x by x equal to 1. We'll try to approach this limit, where keep in mind that whatever you have here, you should have here. So that's what we'll try to do. Now here it is 1 plus x. So obviously I will need uh, uh, 1 plus x, you have x here. So 1 plus ax, so I need ax here to keep parity with the standard limit. But then in that case, I have to multiply this with a to get rid of a and preserve only x. Now similarly, here you can see, you can visualize this as 1 plus minus bx. If I want to compare this with the standard limit, which is with plus, so that means I will need a minus b here. So if I need a minus b here, I will have to multiply a minus b here to get rid of it. So that's the manipulation. So this whole thing is within second bracket. So now it is easy. So limit x tends okay, now I don't need to calculate the show the calculations, you can do it directly. So this portion as x tends to 0 will yield 1, so the entire thing will yield a, and similarly this portion will yield limit 1 as x tends to 0. So what we are left with is, here we are left with a and here we are left with b. That means the limit of the function as x approaches 0 is a plus b. So this is actually LHL as well as RHL, as I told you in the beginning. Now to make the function continuous, the functional value has to be the same. Therefore, to make f continuous at x equal to 0, we have to make the functional value at 0 also a plus b, so that we have LHL equal to RHL equal to functional value. Then only it will become continuous. So finally this is the answer. So I'll stop here regarding continuity. If you have any queries, please contact me. I'll help in any way it is possible for me. Don't hesitate. Okay.
Okay, girls, I made a video on continuity. Uh, that Clipchamp, I use Clipchamp to avoid watermark. So Clipchamp doesn't allow me to record video for more than 30 minutes. So I made three individual videos and then punched them together to make one file. So in between, you will find two gaps. So don't worry, just keep watching. You will get the rest of the portion more or less in a continuous way. And another thing is like one of your friends requested to make a video on 3D, but the thing is, I don't know whether all of you have already finished the chapter on vectors or not. So let me know. If you think you are comfortable with vectors, then I will make a video on 3D directly. Uh, you don't have much time, so uh, let me know, please. You can write it in the group also, right? And continuity, I have done some sums. If you have any other sums, you can send them to me. And also let me know whether I need to do a video on differentiability, because in NCRT we don't have many sums on differentiability, but in the board exams, more or less every year you get one sum on differentiability. Okay, so do let me know. And please like my video and try to subscribe. I mean, you already subscribed, tell others also to. Okay, bye.